Welcome again to Math Essential Coordinate System. We are still with the 3D coordinate systems. Previous time we discussed the Cartesian and cylindrical ones. This time we will discuss about the spherical coordinate system. Now we move to the third and last coordinate system in 3D, which is the spherical coordinate system. We have three perpendicular axes, which are r, which is simply the radius of the sphere, and have two angles. One is angle when we rotate with x-axis, which is phi, and one angle when we rotate with z-axis, which is theta. So how to move a point from origin? So simply, if this the origin, you simply first move in the z-axis with the vector r until you reach the value of r. Then with x, this is our x, so we want to plot our theta. So in the xz plane, move with theta until you reach the target angle theta. And finally in the horizontal plane, this horizontal plane, for example, which we reached with theta, so I rotate with phi now. So I reached my point. Now we move to the calculation of the position vector. And since position vector is simply the distance between the origin and B, we will find that we are just moving in R. So our D is simply movement in the either R direction multiplied by the value of R. Last but not least, we have here the definition of the unit vectors. R simply points outward from origin. Theta, vector that points around a vertical circle. I mean in the vertical plane, xy plane, xz plane, or yz plane, for example, or any plane in perpendicular to the xy plane. And finally, we have phi, vector that points around a horizontal circle. Now we move to the calculation of the infinitesimal length, and to do so, we compute each direction individually. So in case of r, it is just a length, so it will be dr in the direction of r. In the case of theta and phi, we need to calculate the arc length. Theta is the angle with z. So if we take any perpendicular plane to the xy plane, so zx, for example, and we can plot a circle where our theta exists. So say this is our r and this is theta. So we can find that the target arc length in the case of theta will be this L arc. Then simply our theta can be defined as L arc divided by r. Then we can find the theta from this relation by making differentiation of both sides. Finally, our L arc, DL arc, will be equal to r d theta, and this is what you can see here. Likewise, we need to find the plane where phi exists. So from this plot, if we make a parallel here to x, say x dash, and a parallel to y, say y dash, and this one is actually our phi. So our phi exists in some plane which is parallel to x, y, and x dash and y dash. So this is L arc 2, for example. So the remaining here is to know what is the radius here. So this is R2. So what is this radius? Actually, if we look carefully, we can perpendicular here. This one is our z, and this one is r. So we know that any horizontal plane will be perpendicular with the z axis. So we can plot here. This is our r dash. This is our z. Sorry, this is r2, not r dash, and this is our original r from the spherical coordinates. The angle from z to r is just theta. So in this triangle, r dash, r2 will be simply what? R2 will be simply r sine theta, because this is the facing side, right? Facing side to theta. Now we know the radius, we can write another equation. So we have phi equal to L arc 2 divided by the radius. The radius in this case is just r sine theta. And then differentiate both sides. We can get our dl arc in case of phi, dl arc 2 equal to r sine theta multiplied by d phi, and again this is what you can see here. Finally, you can take the magnitude to calculate delta L as a scalar value. Final two components which we are seeking are the surface area and the volume. Let's first start with the volume. This is very simple. You just multiply all the delta L's, delta L1, delta L2, delta L3, which is equal to dr multiplied by r d theta multiplied by r sine theta d phi. Multiplying these three together will bring you with this d volume. In the case of delta S, I mean the infinitesimal surface area, you need to calculate in each direction. Calculate in some direction, we have r, theta, and phi. So if I want to calculate in r, I multiply cross product theta and phi. If I want to calculate in theta, I cross product r and phi. Finally, if I want to calculate in phi direction, I cross product r and theta, and we already know the infinitesimal length in both in each case. So in case of, for example, if I want to calculate in r direction, I'll multiply what? I simply multiply r d theta by r sine theta d phi. Then I can get this value here. Similarly, you can do in theta and you can do in phi. Finally, with the takeaways, so we have discussed together today the spherical coordinate system r, theta, and phi, and normally this will be used in the problems which have radial symmetry, and we have three unit vectors r, theta, and phi, which depend on each of angle theta and angle phi. Thank you.